All right, today we're going to talk about something called the intermediate value theorem, and we're going to abbreviate that theorem IVT as we go through, try to get talking about the intermediate value theorem. Well, the word intermediate means in the middle, intermediate, in the middle. Value means number, and it's a theorem. So basically what this says is this. If you've got a function that's continuous on an interval, we talked about that yesterday, meaning that there's no jumps or gaps or asymptotes anywhere in that interval. And at the low point, we have a value of A here. Whoops, arm is hitting the page. The low point, we're having a value of A, and the high point has a value at B. So again, we're on this closed interval, or on this continuous interval. We know that the low answer is at f of A and the high answer is at f of B. What this is saying is that there exists some answer L that's in between those that we are guaranteeing the graph will have to go through. Because it's continuous, it can't skip over. So essentially, like saying something like this. If you have the number 0 and the number 5, you are pretty much guaranteed that there is going to be an x in between them if you are guaranteed that there are no numbers being skipped. That's essentially what's happening. You're guaranteeing there's a value in the middle of two other values as long as you know that no answers are allowed to be skipped. And not only does it have to hit that answer once, it's possible that it could hit that answer more than one time, where it can keep going up and down through that answer over and over again, as long as, again, the function is continuous on that interval. So the actual theorem itself right here says, suppose f is a continuous on the interval from a to b, and L is a number strictly between f of a and f of b. Remember, f of a and f of b are the answers. So we've got an answer in between two other answers. There exists at least one number c in the interval from a to b, satisfied that the function of c is equal to that L number, which is in the middle. So again, all I'm doing is saying I guarantee you there's a number in here that's between 0 and 5, like 4. I guarantee you 4 is in between 0 and 5. As long as I know that we aren't skipping anything, I know it's there. Now, the reason it has to be continuous is right here. If the graph isn't continuous, it's possible that it skips over the value L and never actually equals it. But if the graph is continuous, we can't have that problem. Right? Here's a real-world kind of example. It says, suppose you invested $1,000 in a special 5-year savings account and fixed annual interest rate R with a monthly compounding. All right, so the amount of money A in the account after 5 years, which is 60 months, would be A to the R of R equals 1,000, and then 1 plus R over 12 to the 60th power. If you didn't take quantitative reasoning, you wouldn't recognize that formula very well, but it's the formula for compounding interest. And our goal is to have $1,400 after 5 years. All right, so we want to use the intermediate value theorem to prove that this is possible, that there's actually a rate somewhere between 0 and 8% that will give us an answer of exactly 14. So basically what you do is you're going to say, well, what if you have the lowest possible rate of 0%? We can calculate what that result would be, and that's what they're doing down here. Go ahead and put 0 in as your rate. And then what if you have the highest rate that you could have is 8%? What they're saying is there some rate somewhere in the middle here, somewhere between 0 and 8%, that will give you the exact answer? So what they did was they went ahead and plugged in 0 itself. If you have a 0% interest rate, then essentially at the end of all of this time, you're going to have exactly what you started with. If you have an 8% interest rate, and they went ahead and did the calculations for us, I think somewhere on here, yeah, they did, you have $1,489.85 in your account. So what this is asking or saying is that because the graph is continuous, and because on the low end you hit 1,000, and on the high end you hit 1,488, somewhere in the middle you will actually hit exactly 1,400. Somewhere in the middle. We don't know exactly what it is. We just know that by the intermediate value theorem that there is a value somewhere in the middle. And only because it's constant, it doesn't jump around. So in the second part it says to find it, and I'm not going to ask you to do that. We can look at this graph and see what happened. So again, if you have a 0% interest rate, you didn't make any money. if you put in an 8% interest rate and you were up in here somewhere, and we're saying we're trying to find out if it's possible to land here. So based on the graph, you would look down and that would tell you what your rate would be. So it looks like about 0.0675 or 6.75%. If you had that exact rate, you could get the exact amount that you wanted. If you have a higher rate, you'll get more. If you have a lower rate, you'll get less. But again, if you're trying to invest, you know that your minimum amount would have to be 6.75%. So let's look at a basic example for us. It says, prove that f of x equals 2x squared minus 3x minus 6 has a 0 on the interval of 2 to 3, with 3 being closed and 2 being opened. So again, essentially what we're looking at is this is a parabola. And it's going to be opening up with an intercept at negative 6. It's going to be something like this. And we're saying, hey, somewhere over here in between 2 and 3, this thing's got a root or a 0. We want to prove that that's actually true without actually knowing it by the picture or finding the exact answer. So what we can do is we can just plug in a number close to 2, a little bit bigger than 2 because 2 is not included, a number like 2.1, and we can see what we get. So let's do that. Let's find f of 2.1. So that means 2 times 2.1 squared minus 3 times 2.1. And then minus 6. So bear with me for a second while I type all that garbage on my calculator so that we can actually get an answer. And let's see, so 2 times 2.1 squared. I'm talking out loud as I type the buttons because it seems weird to be quiet when you're making a video. And I got negative 3.48. Now let's type in a number closer to the 3. And since 3 is bracketed, we can actually just go ahead and use 3. It means it's included. So that means 2 times 3 squared minus 3 times 3 and then minus 6. I'm not going to do that one in my head. Let's say that'd be 9. That's 18. Minus 9 is 9. Minus 6 is 3. So that we know now that there's this f of 2.1, which gives us an answer of negative 3.48. And we know that when we do f of 3, we get an answer of positive 3. And what this means is that somewhere in the middle is a 0. And that middle number is C. But because, again, we know that there's no jumps or gaps in this, we know that it has to go from over here at 2, it's down here at negative 3.48. But when you get over here at 3, it's all the way up at 3. So we got the low point, we got the high point, we know that there's no gaps in the middle, so we're guaranteed somewhere we're going to have to cross through that spot. All right, now when it says find the exact value for that 0, what that means is to either factor and find the roots, or to go back and use this. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So that's not really part of this class. I just wanted to remind you of how to find it. I could also have factored it, but that pesky 2 as the constant a, that would have made it a little bit harder to factor. So again, you could do it with this formula. If you forget how it would have looked, it would have been 3 and then plus or minus, and then 3, negative 3 squared is 9, minus 4 times a times c, which is negative 6. And then all over 2 times a. And you could have got your two answers, one of them going to be some negative answer over here, and the other one should be our positive answer somewhere between 2 and 3, 2.9 or 2.8 or something like that. Again, I'm not too worried about that second part, more worried that you understand what's happening in the first part, and how you're trying to kind of sandwich the answer in between two other answers to prove that it exists. All right, hopefully the work isn't too bad today. There aren't very many problems, because once you catch on to this, it makes sense. So let me know if you need any help. Good luck.